Question 1. A single stage, single acting compressors. Okay, single stage, you know what a single stage is. It's not two stage or multi-stage, it's only single stage. A single acting compressor. What is a single acting compressors? Double stage is similar to two-stroke engine, but a single stage is similar to a four-stroke engines. So it deals with 85 cubic meters of free air per hour. It deals with 85 cubic meters of free air per hour. So the volume, the atmospheric volume, VA, we say is 85 cubics per hour. And then, per hour. And then we say per hour at atmospheric conditions. Pressure, PA, is 101.325. And then the TA, atmospheric temperature, is TA, which is 16 plus 273, is 288. And then the pressure and the temperature in the cylinder during the suction stroke is 97 P1. The pressure during suction P1 is 97 kPa. And then T1 is equal to 41 degrees Celsius, which is 41 is 41, let me see, 41 plus 41 plus 273, 314 Kelvin. Okay, the index of compression, N is equal to 1.22. This is for polytropic process. The delivery pressure is 550. P2 is equal to 550 kPa. And R for air now is given as 0.287 kilojoules per kilogram Kelvin. And then if the mechanical efficiency, MEC, is 85%. 85%, find neglecting the clearance volume. So clearance volume, it means that we might be dealing with a compressor without clearance. So we draw a PV diagram. The PV diagram is the one that is going to guide us as to how we go about this one. So this is our PV diagram. And then for a PV diagram of a compressor without clearance, this is what we have. So 1 is here, 2 is there, 3 is there, and 4 is there. So the name of that line, of the compression line, is PV is equal to 1.22. PV N is 1.22 is equal to C. So the work done by this compressor is this area here. The area underneath the curve is the work done by the compressor. Okay. Now we calculate the power required by the compressor. Where is the power? The power for the compressor without clearance, we say that IP, indicated power, or we can say work done, is up to you, is equal to N over N minus 1, P1, V1, bracket, P2 over P1, N minus 1 over N minus 1. Right, this is our formula. Now we check, we have N, we have P1, we don't have V1, we have P2, we have P1. So according to the information that we have, 97 kPa is our P1, this is our P1. And our P2 is equal to P3 is 550. 550. Now we have free air conditions. Now atmospheric conditions are in between here. At that point here, we have 1.3.325, meaning that if the pressure P2 is equal to, so the P1 is equal to 101, the valves won't be able to open. In order to create a vacuum, there must be a difference in pressure between P1 and atmospheric pressure. The reason why the inlet valve opened is because the pressure was below atmospheric pressure. In other words, it was a vacuum pressure. We can see that 97 is below 101. But if 97 was equal to 101, then it means that inlet valve won't be able to open. Okay, you can see that the volume VA is here, your V1 is here, and then your V2 is there. So now we have VA, we don't have V1. How do we calculate V1? We say that atmospheric conditions, PA, VA divided by TA is equal to P1, V1 over T1. We do have PA, we do have VA, TA, P1, T1, therefore we can calculate V1. And according to our sketch, you can see that V1 is greater than VA. So when we do our calculations, we found that VA is greater than V1, we know there's a problem. So V1 is going to be what? It's going to be V1 is going to be P1, V1 is going to be PA, VA multiplied by T1 divided by TA. So this is our V1. So 101.325 by 85 by 314 divided by, I think I made a mistake here. I think I made a mistake. This T here is 289. 89. So we divide by 289 multiplied by 97. So our V1 is 96.7 cubic meters per hour. Units are very, very important. Cubic per hour. Now units are very important. So now we substitute. We say that 1.22 divided by 0.2 multiplied by P1, which is 97. The power is supposed to be in what? It's supposed to be in kilowatts. Multiplied by 96. 96.47. We divide by 3600 because remember, kilojoules per second gives you 1 kilowatt. So what we are trying to hear, we are converting that hour into per second so that our answer is going to be in kilowatts. So we divide by 3600. That is, we are converting from hour to seconds. In bracket, P2 is 550. Divide by 97. Bracket 0.2 divided by 1.22 minus 1. So our indicated power or compressor power is 14.41 multiplied by 0.367. And the final answer is 5.29 kilowatts. This is our answer. But we are told that the efficiency, the mechanical efficiency is 85. If that is the case, then it means that the overall power or the power coming through. So now we are looking for, wait, let's check the question again. Okay, the question doesn't say calculate compressor power. It says the power to the compressor. Let me draw a small sketch here to show you. If this is the compressor, and the compressor is IP, it's compressor power, and then we have a shaft here, and then we have a motor here. This is a motor, and now the compressor power now is 5.29 kilowatts. The question says calculate the power required, actually available at the shaft here. The power coming from the motor. This is the power that we are looking for. And then we know that mechanical efficiency is going to be compressor power divided by shaft power. Shaft power. So the question says, it doesn't say calculate compressor power, it says calculate power required to drive the compressor. In other words, we want the power here, the power that is required to drive the compressor, not compressor power. So what we have here, we have a compressor power. Let's calculate the power required to drive the compressor. So we say that SP, shaft power, is equal to the IP divided by mechanical efficiency. Therefore, we say shaft power is 5.29 divided by 0.85. 0.85, and the answer is 6.23 kilowatts. This is the power required to drive the compressor. I think understanding is also very important. The question doesn't say power compressor, calculate the compressor power. It says calculate the power required to drive the compressor. In other words, calculate the shaft power. The second one, it says that calculate the volume served by the piston if the speed of the compressor is 120 and the volumetric efficiency is 78. Now, we assume that the volumetric efficiency is 78. If that is the case, the sketch now will be like this. There will be a line here where we say this is 3, this is 4. Because once we have a volumetric efficiency, you must have a clearance volume. So the question says calculate V swept. So V swept, we say that the volumetric efficiency of this compressor here is going to be VA divided by VS. Divided by VS. So VS swept volume, that is what we are looking for, is going to be 85, which is VA divided by 0.78. And the answer is 108.97 cubic meters per hour. We need swept volume in cubic meters, not in cubic meters per hour. So how do we convert that? We multiply by the number of cycles or revolutions made by, we divide by a number of revolutions made by the compressor. So we say that swept volume, that is the final answer, is going to be 108. You look at the units, 97 cubic meters divided by per hour, divided by RPM, so 120 revs per minute. Revs per minute. So because it's per minute and per hour, we multiply by 60 here. Let's do this. Multiply 120 by 60 in order to convert that hours to a minute. So so here we're gonna have minute cancels minute. Our answer is going to be 108 divided by 60. It gives 108 divided by 120 by 60 is going to be 0.01514. If you leave like this, it doesn't mean that you're going to get 0. If the question, let's say, is 5 marks, you will get 4 marks out of 5. But ultimately, your answer must be in cubic meters. So cubic meters, you divide by 120, but because it's per hour, you have to convert it to a minute. Or you convert revs to per hour so that the units are the same. You can't have 2 different units in the same formula. So our answer is 0.154 cubic meters. This is the swept volume. Swept volume, in other words, it is the distance from this point here up to that point. So this is our swept volume. Okay. So let's move on to the second one. And then after the second one, then I think we'll do another one that is that will appear in the exam. For now, I will not ask you a question that doesn't have a clearance of time, because we know that there's no such a question. All the questions must have, all the compressors must have clearance. A single cylinder, single air compressor with a piston, diameter of, okay, let me increase font a little bit. Right. It has a diameter of 150. So diameter D is 150 millimeters. And then the stroke length L is equal to 200. And then it takes air at 97. P1 is 97 kPa. And then T1 is 15. T1 is 15, which is 288 Kelvin. Now it is delivered at 670. P2 is equal to 670 kPa. The compression takes place according to the PV. In other words, N is equal to 1.2. And the engine speed, N, is 160 RPM, or the compressor speed. Ignore the free volume. So we have the same situation where we have a PV diagram of a compressor without clearance. One, two, three, and 4. So PV 1.2 is equal to constant. So that is our PV diagram. Now the first question says calculate the mass of air compressed per minute. So we say, okay, where do we get M? So from characteristic gas equation from chapter 1, of course, we know that V1 is equal to M RT1. I think those who are repeating here were already familiar with this formula here. So we have P1. Do we have V1? Do we have V1? No, we don't have V1. And then V1, but V1 in this case here is equal to Vs. So Vs, firstly, Vs is equal to V1, is equal to pi d squared L over 4, which is equal to pi multiplied by 0.15 squared multiplied by 0.2. So Vs is the length covered by the cylinder. So this is your Vs. This is a Vs, which is also equal to V1, which is equal to V1. So Vs is from this point up to number 3 there. And that distance from there is the same as V1. So Vs is equal to V1. Divided by 4 is equal to what? 0.0353 cubic meters. This is our Vs. So we have V1, P1, we have T1, we have R, we don't have M. So M is going to be 97. 97 multiplied by 0.0353 is equal to M multiplied by R 0.287 multiplied by T1, where is T1? 288, and then we get our M as 0.00417 kg. This is our M. But the question says calculate M per minute. So you can still get marks, but you won't get full marks. Per minute, what do we say? We say, okay, per minute now is the mass flow. There's a dot on top there. Once you see that dot, it is the mass flow rate. The one is just mass, total mass. So M dot, it is the mass flow rate. So it is going to be our mass multiplied by number of revolutions. compressor speed to convert it to per minute. In other words, we are going to say 0,004147 multiplied by the compressor speed 160, and then the answer is 0,6628 kg per minute. So the units again, don't be lazy to write the units. The units here is kg multiplied by revs per minute. So the answer is in kg per minute. That's what the question is looking for. Now the question, the power required to drive the compressor if the mechanical efficiency is 80. Again, we have to calculate the compressor power, and then we calculate power required to drive the compressor. The formula is the one that we have. The compressor power, IP, is equal to N over N minus 1. P1, V1, bracket, P2 over P1. N minus 1 over N minus 1. Which is equal to be 1.2 divided by 0.22 multiplied by the pressure, 97, and volume 0.00353. And then we say bracket 670 divided by 97, 0.22 divided by 1.22 minus 1, right? And our answer is going to be in what? Our answer must be in kilowatts. So what we have here, our answer is going to be in kilojoules. To convert it to kilowatt, we have to multiply by N divided by 60. So N is per minute divided by 60 gives you per second, which is kilojoules per second. So we multiply by the 160 here. 160 divided by 60 to convert that minutes to hour. And then the answer is IP is 2.08 kilowatts. And now we are looking for the power or the shaft power required. You can say shaft power is equal to 2.08 divided by mechanical efficiency. Now the power required in the shaft is 2.6 kilowatts. 2.6 kilowatts. So the first two questions we have been dealing with theoretical stuff, and theoretical stuff in the sense that we are dealing with compressors without a clearance. So in practice, there's no such thing. So now we have to have a look at the real compressor, the one that has clearance, the one that is a typical exam question. And that one, I think it will be question what? Let me see. Question 6. Let's see. Question 6, a single stage reciprocating compressor receives 15. Yes. I think this is the one. This is the one that real compressor, actual compressor. Right. A single stage compressor receives 15.6 cubic meters per minute. I want to go back to that sketch, sketch that I showed you now. Where am I going now? Okay, I'm going to content. I'm going to tutorials. Can somebody tell me which volume is this? Okay, where are we now? It's building compressor PDF, yeah. This is the PV diagram of this question. So now the question says the air receives 15.6 cubic meters at 103 and 21. Can somebody tell me which volume is this 15.6 from this sketch? From this sketch. Is it V1? Is it Vs? Is it V3? Is it V1 minus V4 or V1 minus V3? Which volume is this? Which volume is this, guys? That's what I said. I said that if you don't understand these volumes, we are going to have problems. A compressor receives 15.6 cubic meters per minute at that pressure and at that temperature. Then you go to the comments and see who says what. The comments, I'm going to the comments now and check. Where are the comments? Okay, one says VS, the other one says VS, the other one says V1. Okay, so all of you are wrong. All of you are wrong. That volume it receives. This is the volume that we're talking about. This is the volume that we're talking about. Where is that? The volume receives. Remember, I said that it receives the air between 4 and 1. So this particular compressor receives the air between 4 and 1. This is where it receives suction. In other words, effective is called effective salt volume or induction volume. So it receives air between 4 and 1. That's where it receives air. Between 1 and 2, it compresses that air. Between 2 and 3, it delivers that air. Between 3 and 4, the air that will not leave the cylinder is the one that is pushing the piston to 4. So the volume that we are given receives is V1 minus V4. Guys, this is very, very important. If you miss this sketch here, we are going to have problems. So we will say that V1 minus V4 is equal to 15.6. That's where the compressor is receiving the air. And then the pressure, this is the P1. P1 is equal to 103 kPa, and T1 is 294 Kelvin. And then we have the delivery pressure is P2. P2 is equal to 780 kPa, while the speed of the compressor is 350 RPM. We assume that the free volume, in other words, V3 is equal to 0.05 swept volume. We assume that the clearance volume, or V3, is 0.05 of stroke volume. The compression is taking place according to the law. PV is equal to PV 1.35 is equal to constant, and R is equal to 0.288 kilojoules per kilogram Kelvin. Right. Now the question says calculate the stroke volume, in other words, VS. So let me draw the sketch. It makes sense when the sketch is there. One, two, three, 4. V1, V3. So V1 is from here to here. That is V1. So this is V1 minus V4. So this is intake. Right. So all we know is that V3 is equal to 0.005. And now you have to calculate what? You have to calculate the stroke volume Vs. That is what is required here. So we know that from chapter 1 or chapter 2, whatever, we know that P3 and V3 is equal to N, is equal to P4 V4 to the power N. What are we looking for? We are looking for 4. We are looking for V4. Where we say that V4 is equal to P3 over P4 1 over N multiplied by V3. So V4 is equal to P3 780. P3 is equal to P2 and P1 is equal to P4 according to the sketch. Divide by 103. 1 divided by 1.35 multiplied by V3. We don't have V3. So from here we can say V4 is equal to 0.224 V3. Very important. What are we trying to do here? Because we don't have V4, we don't have V1, we have to express one in terms of so that we end up having one unknown. We end up having one unknown. So now we go back. We say that, okay, V1 according to the sketch is equal to Vs plus V3. This is V1. So Vs is going to be this distance plus that distance. So V1 is equal to Vs over V3. Okay. So V1, in other words, is equal to V3 Vs is equal to, Vs plus 0.05 Vs, because V3 is here. So you say V1 is equal to 1.05 Vs. Very important. Okay. So now we have eliminated what? V1. Come back to our initial formula here. So we replace V1 with 1.05 Vs minus V4. V4, where is V4 is here, minus 0.224 Vs. Vs is equal to 15.6. We add the 2 now, we have 0.8959 Vs is equal to 15.6. Therefore, swept volume is equal to 18.89, which is cubic meters per minute. Per minute. Because why is it per minute? Because our initial formula, this is per minute. So our final answer is going to be per minute. But we don't want our answer to be in cubic meters per minute. We only want to have it cubic meter. So we will say that Vs is equal to 18.89 divided by 350. 350 revs per minute. So this minute, we cancel that minute. Our answer is going to be 0.05397 cubic meters. So now you'll understand when I say this particular chapter is actually not friendly. It's very hostile to students. It is not hostile if you understand what is going on here with these volumes and here. You should not have a problem. That's the reason I'm saying that it is hostile. The only hostility comes from the volumes. You know the volumes, you'll never get it wrong. And then the second one, the one T2, the delivery temperature. T2 over T1 is equal to P2 over P1 n minus 1 over n. So T2 is going to be 780 divided by 103 0.35 divided by 1.35 multiplied by 294 is equal to 496.94 Kelvin. This is our delivery pressure. And the last question, delivery temperature, sorry. The last one, the power required for propulsion. In other words, now they want the compressor power, not the power required to compress, because there is no mechanical efficiency here. So now we want the compressor power. So the compressor power IP is N over N minus 1 P1 bracket. P1 now goes this clearance, V1 over V4 bracket P2 over P3 N minus 1 over N. That's what we have. So V1 minus V4 is in what? Is in cubic meters per hour. It must be per second. Sorry, it's per minute. It's per minute. So you have to convert this minute to second by dividing by 60, dividing with 60. So we say 1.35 divided by 0.35 multiplied by 103 bracket 15.6 is given. V1 minus V4 is given from the question. Now, because it's per minute, we have to divide by 60 to convert it to per second in order to have a watt, not kilo joules per hour. P2 780 103, and then we say 0.35 minus 1, and the IP is 71.3 kilowatts.